Greetings, in this one we'll be talking about Sylow's third theorem. So there's 3 Sylow theorems when we count them in general. And the most fundamental one, the first Sylow's theorem, asserts that if you have for a group G, you have this thing that if some power of some prime divides its order, then there exists a subgroup of this group such that its order is equal to this power of that prime. Okay, so imagine a group G and it is divisible by the power of a prime, and a prime can be 3, 5, 7, okay, and 13 and so on. So for example, take number 13 as a prime. So if we have a group, let's say if we have well, we can go from the other side. That's easier to make an example. If you're thinking of an example by first of all thinking of some prime. So let's say that prime is, so an example for this would be if our prime is equal to 13 and R is equal to, let's say, second power of it. So then P to R would be 169 because I said 13. Well, then that means that there exists that means that now let's think of some group whose order is divisible by 169. I mean, it can be a group of order 169, or it can be then it's a very trivial subgroup of the same order as the original group, or order 338. So let's say then we could have, for example, G of order 338. Well, if the order of G is 338, then there exists a subgroup by this theorem such that its order is 169. And it goes back to the idea that by first Sylow theorem, if we have a group G and it's divisible by the power of a prime, some integer power of a prime, then there exists a subgroup of that order which is a power of a prime that divides the order of the G.